All right, so guys, with this assignment, it should now be posted for you, yes? Okay, so you open this with Cami, so we can then go along and edit this stuff. So the acceleration, how is it related to net force? Do you think it's directly or inversely? Directly means if I increase one, the other increases. Inverse means if I increase one, the other decreases. So just think, if you're pushing something, net force, the harder you push, what do you think would happen to the acceleration? Right? You increase your push force. Do you think acceleration is going to increase or decrease?
I don't know.
If you push something harder, you think it's going to accelerate less?
Yeah.
More. So then, all right, so the first part has to be directly. So that means B and D are gone. Okay, so then we have to figure out how mass is related. So if you're pushing an object, if it gets heavier, is it going to accelerate more or less? Less. So if I increase mass, acceleration goes down, which is inversely. So here we're looking for letter A. So what you're going to do is if you highlight that, go to markup, which is two things above the text box looking thing. If you click markup and then go over, there should be a text highlighter. And if you click that and just kind of highlight it, boom. Or if that's too much of a pain in the ass, you can go to drawing, go. Oh yeah, what am I? Smart guy right there. Or we can just go to shapes real quick, go to circle or rectangle, and just be like, boom. What a smart guy right there. I totally just, that brain left. Yeah, my brain left me right there. So guys, how this proportionality thing works is if you know that directly proportional to mass, directly proportional to the force, inversely proportional to the mass. So they're saying right now the acceleration is 8. What would happen? What would the new acceleration be if the net force is increased by 2? So if it increases by 2, you're going to basically double the acceleration. So if 18 times 2 is 16. So I'm just going to go to text box. And in that first little box there, I'm going to put 16. So everyone should be doing that right now. So this guy here should be 15. Okay, well now it says that an object, all right, the same thing, is still accelerating at 8, but now the net force has increased by 4. So whatever happened to the net force is going to happen to the acceleration. So if it increases by 4, the acceleration is going to increase by 4. So what is 8 times 4? 32. Ba-bam. Okay, now what happens? The acceleration is still at 8, and now the net force decreases by 2. So what should happen to the acceleration? Now you're going to divide by 2. So that should be 4. Good. Okay, the next one. Now the next one's talk about mass. So whatever happened to the net force, like the same thing happened to the acceleration. Mass is like the opposite. Acceleration and mass are the opposite. So if mass increases, instead of multiplying by 2, we divide by 2. Okay, so acceleration was 8, mass increased by 2. So since it's on the bottom, we're going to divide by 2. It's the opposite. An object accelerating at 8. Now the mass increases by 4. So what am I doing? Instead of multiplying by 4, I'm going to divide by 4. So what's 8 divided by 4? Oh, crap. So then what do we, we made a mistake here. 8 divided by 2, this one here should have been 4. Okay. So now in letter F here, acceleration was originally 8. Force increases by 2. So what would that become? What would the acceleration become?
16.
Good, 16. And now it says the mass is decreased by 4.
16 divided by 4.
Not divided by 4 because it's decreasing. So remember, mass is the opposite. So if it decreases by 4, we're going to multiply the acceleration by 4. Just think about it. If something gets 4 times as light, you should be able to push it 4 times as fast, right? So then you would do 16 times 4 would be 64. Okay, so now what happens? We're at 8. Net force increases by 4. So what would we do with the 8?
8 times 4.
All right, so we got 8 times 4, which is 32. But then it says the mass increases by 2. So now it got heavier. So it should be harder to push, right? So remember, we do it the opposite with the mass. So if its mass is increased by 2, we're going to divide by 2. So 32 divided by 2, 16. Is that making sense? Okay. What about the next one? No. Net force is increased by 3 and mass decreased by 4. So net force increases by 3. So what's 8 times 3? 24. Mass is decreased by 4. So we're going to multiply by 4.
96.
96. Okay, in this last little bit, these are force diagrams, all right? They're all going to have the same mass. Remember, acceleration is equal to the net force divided by mass. So basically, you need to find which one of these has the highest net force, and then we will put them from largest to smallest. Which one of these has the highest net force? Look at all of them. The gravitational force or the weight and normal force are equal. So we're basically looking at the horizontal. So 50 up and 50 down is 0. We have 20 for this one. So I'm just going to write this one has 20. I'm just writing on the side. 50 up and 50 down, 50 left and 50 right. This one is 0. 50 up, 50 down balanced. 40 right, 10 left. What would the net force on that one be?
30.
And then what is this one? 15. So who had the highest? C. So we're gonna see who's the next highest. A, then D, and then B is the last one. Boom.
What was G?
G is 16. Do you know why? Whatever we did to the net force, we have to do to the acceleration. So in G, we're starting off with the acceleration is 8. So if the net force increases by 4, you would do 8 times 4. But the mass increases by 2. So whatever happens to the mass, right, if it says mass is increased, we do the opposite to the acceleration. So instead of multiplying that by 2, we divide by 2. And that's why we got 16. All right, guys.